Chapter 1. For Chapter 1, I'm including all three sections in one single video. Each section talks about a different topic of understanding the course of statistics and dealing with different definitions. Let's begin with section 1.1, an overview of statistics. Here are the objectives for the section. Let's begin with what is data? Data consists of information coming from observations, counts, measurements, or responses. For example, according to a survey, more than 7 in 10 Americans say nursing career is a prestigious occupation. Next, we have social media consumes kids today as well, as more score their first social media accounts at an average age of 11.4 years. So those are two examples of data. Next, we have statistics. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. How you collect your data is very important, as you want to make sure you're trying to collect the most best response to answer your question, not the most convenient, and you for sure do not want to manipulate your data to give some type of false conclusion. Next, we have two different types of data sets, and these are very important, as you have seen when finding the standard deviation. We have what's called a population, the collection of all outcomes, responses, and measurements or counts that are of interest. Next, we have sample, a subset or part of the population. So, a population would be everything in that category that you're studying, and within that, you have your sample. An example of a population would be like people in the United States. While keeping track or finding information of that data might be really hard to find, but you can definitely work with a sample. And as long as it's a conclusion that leads to something that seems pretty truthful about the entire population, then you would provide that information instead of finding the entire population. You have an example and a solution. For the sake of time, I'll let you read them on your own. You can go ahead and pause the video and read the example and the solution to the example. Moving forward, a parameter and statistic. A parameter is a numerical description of a population or statistics, and a statistic is a numerical description of a sample characteristic. So notice one's for a population, one is for a sample. You have three examples. I'll let you pause the video and read them on your own. There are three examples along with their solution. In statistics, we have two branches of statistics. We have descriptive statistics, which involves organizing, summarizing, and displaying data, such as tables, charts, and averages, and inferential statistics, which involves sampling data to draw a conclusion about a population. All right, that's what we covered for the first section. Next section, section 1.2, data classification. For this section, our objectives are how to distinguish between qualitative data and quantitative data, and how to classify data with respect to the four levels of measurement: nominal, ordinal, interval, and ratio. First, we have qualitative data. This consists of attributes, labels, or non-numerical entries, such as major, place of birth, eye color. Next, we have quantitative data, which is numerical measurements or counts, such as age, weight, or temperature. These two types of data, qualitative and quantitative, are kind of hard for people to keep track of. For me, whenever I think of quantitative, I just think if it involves numbers, then it probably falls under quantitative. qualitative is just a descriptor. And you have a quick example here where a table shows sports-related head injuries in the U.S. emergency rooms during a recent 5-year span for several sports. Which data are qualitative and which are quantitative? While it's not always true, but taking a look and considering if there's numbers, that's a good marker that you might be working with quantitative. Here, the descriptor, this will be quantitative, right? I'm sorry, qualitative. We have your solution right here. All right, next we have 2 levels of measurement. We have nominal level of measurement. This is only for qualitative data only. So qualitative, that's some type of descriptor. It can be categorized using names, labels, or qualities, and no mathematical computation can be made. For ordinal level, qualitative or quantitative, so both are part of ordinal, data can be arranged in order. So that's also another marker that we're working with ordinal. And difference between the data entries are not meaningful. So for nominal, we have a lot of qualitative type of data. For ordinal, we have quantitative and qualitative. And order matters. So here you have an example to classify data by level, and you have 2 options: top 5 U.S. occupations with the most job growth, and movie genres. And you have your solution here. Levels of measurement. The interval level of measurement is defined by qualitative data. Data can be ordered, and difference between data entries is meaningful. And 0 represents a position on a scale, not an inherent 0. Like 0 does not mean no value. We also have ratio level of measurement. Similar to interval level, but 0 entry is an inherent 0, so 0 implies none. A ratio of data values can be formed, and one data value can be expressed as a multiple of another. So here we have 2 data sets in your example. We have classifying data. For first, we have the New York Yankees and World Series victories, and next we have American League home runs in the year 2016. So between these 2, you want to be able to classify the data by level. And one quick tell for me is the whole value of a ratio. So when you think of a ratio, always think as a fraction. Can you write your conclusion as a fraction? For example, in this chart here, we can, right? If you think of it as a part divided by a whole, you can write some summary about the home runs, right? So for example, Baltimore had 253 out of whatever total home runs there is in this story. And so our conclusion is that for the home runs, it's a ratio level, and for the first chart using dates, that's an interval level. All right, section 1.3. 1.3 objectives are how to design a statistical study and how to distinguish between an observational study and experiment, how to collect data using a survey or simulation, how to design an experiment, and how to create a sample using a random sampling, simple random sampling, stratified sampling, cluster sampling, and systematic sampling, and how to identify a bias sample. So this entire section, 1.3, is about different definitions and different types of ways of collecting data and how you can manipulate that data as you may see fit for your research. The most important part of this section, I think, is designing your statistical study. So here are your steps when you want to conduct a study. First, you want to identify the variables of interest, the focus, and the population of the study. Develop a detailed plan for collecting data. If you use a sample, make sure the sample is representative of the population. You want to collect your data. 4. Describe the data using descriptive statistic techniques. 5. Interpret the data and make decisions about the population using inferential statistics. And 6. Identify any possible errors. Data collection. First type of data collection is observational study. A researcher observes and measures characteristics of interest of part of a population. Research such as, for example, researchers measure the amount of time people spend doing various activities such as paid work, childcare, and socializing. Next, we have experiment. An experiment applied to a part population is called a treatment group. A response and responses are observed. Another part population may be used as a control group, which is the no treatment is applied. The subjects in both groups are called experimental units. In many cases, subjects in the control group are given a placebo, which is harmless, a fake treatment that's made to look like a real treatment. An experiment. An experiment was performed. Oh, here's an example of an experiment. An experiment was performed in which overweight subjects were given the artificial sweetener sucralose to drink while the control group drank water. While performing the glucose test, researchers concluded that the sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. Next, we have data collection. So different types of data collection are listed. First is a simulation. This uses a mathematical or physical model to produce the conditions or a simulation of the process. It often involves computers. It allows you to study situations that are impractical or even dangerous to create in real life. They often save time and money. An example of this would be when automobile manufacturers use simulations with dummies to study the effects of crashes on humans. Surveying. In a survey, an investigation of one or more characteristics of the population. Surveys are carried out by people by asking them questions, commonly done by interview, internet, phone, or mail. Designing a survey is important to word the questions so that they do not lead to biased results, which are not representative of the population. For instance, the survey is concluded on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. In designing a survey, it would be acceptable to make a list of reasons and ask each individual in the sample to select their first choice. All right, so here are different parts of your experimental design and things that you control about your experiment. So 3 key elements for well-designed experiment are control, randomization, and replication. Confounding variables. Confounding variables occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. For instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it was because of the remodeling or the new mall. The placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has been given a fake treatment. To help control and minimize the placebo effect, a technique called blinding can be used. And there's different types of blinding. Blinding is a technique where the subject does not know whether he or she is receiving the treatment or the placebo. Double-blind experiment, neither the subject nor the experimenter knows if the subject is receiving a treatment or a placebo. Randomization. This is a process of randomly assigning subjects to different treatment groups. Completely randomized design is when subjects are assigned to different treatment groups through random selection. Randomized block design. This divides the subjects with similar characteristics into blocks and then within each block, randomly assigning subjects to a treatment group. Key elements of experimental design are randomization. One type of a randomized type of experiment is randomized block design. An experimenter testing the effects of a new weight loss drink may first divide one divide the subjects into age categories. Then within each age group, randomly assign a subject to either a treatment group or the control group. Next, we have experimental design. Match pair design. Subjects are paired according to similarity. One subject in the pair is randomly selected to receive one treatment while the other subject receives a different treatment. Things to consider in your experiment are also sample size. The number of subjects in the study is very important to the experiment design. Also, replication, the repetition of an experiment using a large group of subjects. For example, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 2,000 people are given a placebo. Because of the sample size, the effects of the vaccine would most likely be observed. Experimental design. A company wants to test the effectiveness of a new gum developed to help people quit smoking. Those are examples. I'll let you read the examples on your own so that'll make the video much longer than it already is. You have an example along with, so there are examples of types of experiments, and you're supposed to think about what the error may be and how to make this experiment better. It gives you the solution, the problem, and how to correct it. Sampling techniques. You have a census, and this is a countermeasure of the entire population. A sampling is a countermeasure of part of the population and is more commonly used in statistical studies. Even with the best methods of sampling, a sampling error may occur. A sampling error is the difference between the results of a sample and those of the population. So different types of collecting samples. One of them is called a random sample. A random sample, every member of the population has an equal chance of being selected. We also have what's called a simple random sample. Every possible sample of the same size has the same chance of being selected. In a simple random sample, the random numbers can be generated by a random number table or software. They assign a number to each member of the population, and then from there, members of the population that correspond to these numbers become members of the sample. We also have what's called a stratified sample. You divide people into strata and select the random sample from each group. Another type of sample is cluster. A cluster sample divides the population into groups or clusters and selects all the members in or more, but not all of the clusters. We also have what's called a systematic sample. Choose a starting value at random. For example, choose every kth member of the population. So if you had a sample group of 100, you will only test like every fifth, for example. So every fifth member, like the 10th person, the 5th person, the 10th person, the 15th person, and so on. There's also convenient sample, which is what you want to avoid. You only choose members of the population that are easy to get and often leads to biased studies. For example, if you're asking something about men and women and you stand outside a women's restroom, for example, that wouldn't give you the best result. It would be biased. So convenience you want to avoid, but of course, sometimes it's what you have. All right, that's it for section 1.3. You have examples about identifying different types of sampling techniques. You also have a solution there written there. So you can go ahead and see if you were on the right track. All right, that's it for chapter 1. It was just a bunch of definitions. You already did chapter 2, which is doing a lot of the basic calculations for the course. Hopefully, you can start putting those 2 chapters together and start seeing where this class is heading. All right, thank you.